Hello team, welcome to this video. My name is Tanishka and I am a student of a full stack developer. So this video is all about my Capstone project 3 of Elevator module 3, that is design and analysis of a algorithm with Python. Here in this video I have solved all 25 courses. Some have errors, in some we have to compare them, and in some code we have to rewrite them. So as for now I have chosen 5 codes and explain all, but they have asked us logical issues in code, correct approach and explanation. So let's start with our first code. So our first code is a power of 2 puzzle. So, to solve the power of two problems, a common and efficient method involves using the properties of binary representation. So, we all know that in binary representation, a power of 2 in binary exactly one bit set of 1. So, subtracting 1 from a power of 2 flips all bits after the single 1 bit. So, the problem with the code is the mistake in this code is the use of logical or instead of logical and. With the or logical or, the function will return true if either condition is true, which causes incorrect result. So I have rewrite the code here, and you can see I have just changed the logical here from or to and. So here you can see return n is greater than 0. It ensures only positive number are considered. So here you can see n and n minus 1 checks if n has only one bit set to identify a power of 2. So let's move out to our second code. So the question is minimum moves for valid parenthesis. Parenthesis means opening and closing bracket. So the problem is to find the minimum number of parentheses that need to be added to make a string of parentheses valid. So the first code which given in it is the here. Here you can see the some of the code are invalid. The parentheses here are some are invalid, so we have a rewrite here. It is my corrected code. The problem with the code has logical issues. It incorrectly uses the close counter and the condition in the else block. It does not properly track and match opening and closing parentheses. So the correct we have taken correct approach in it by use a variable open to count and match, increase open by 1 for every start, and for every close parenthesis check we have check it. So here is my the correct code you can see. And in it open tracks in it open tracks open apprentices mean this one tracks how many apprentice waiting for matching when encountering close apprentices. If open is greater than 0, one is matched, so reduce open. Otherwise, this is unmatched closing parenthesis, so increase close. So let's move over to our closed code third. It is a score keeper unconventional call points something. So here we have asked the problem is to simulate a score keeping system where operation modify a record of scores, and we need to compute the sum after all operations are processed. So the problem with the code is so I have identified some problem with the code that has been given out here. In this code there are some problems like modifying the operation array in place while iterating leads to indexing and mutation error. Using supplies removes the wrong elements and shift indices unexpectedly. The loop boundary condition I is less than is equal to operation dot length. Here this one. This causes out of bonding access. So the correct approach is by using a stack to keep valid score for each operation. If an integer push it as a number c, the c pop the last score, and d pushed double the last score, and plus push the sum of last two scores. So here is my correct code. So here you can see I have made some mm, approaches from my side, that is C. You can see I have represent here C. So in C it pops the last score. The score that has been last updated is as we pop out D. D push double the last score. It gives the double of the last score, and here it is a plus, and a plus push the sum of last two scores. So so let's move to our fourth code. So the fourth code is all about a height based talent showing sorting. So in short, to they have asked us to help mark sort participants' names in descending order based on their height. Best approach is the best approach we have take is pair each name with its height. Sort this pair array by height in descending order, and extract and return the sorted names. So the issue with the code here is height length parenthesis. Here it is a height length parenthesis. This one should be height dot length. It is height length parenthesis, but it should be height length because and is a property not function. Length is property not function. The loop runs with the I is length. Here is the loop I is length, which is off by one, it should by I in length, which I have written here is, and using a map to store height and names work here because height and distinct but correct loop indicates are necessary. So here I have make all the changes here. Here you can see I have just make it a height dot length instead of height dot length parentheses. So here you can also see I have used I is less than length. So and also I have used some map methods here. You can see push map dot get height. So in this we create an array of object pairing names and height, sort by height descending using a custom comparator, and extract and return the sorted list of the names. So let move over to fifth code. Fifth code has number shuffle missing and duplicate. So the problem involves identifying the duplicate and missing number in an array, where the array should contain number from 1 to n. But one number has been duplicated and another is missing. Okay. So approach to solve the approach I have taken to solve the problem is using a map or frequency array to track occurrences. Count how many times each number appears, and the number which does not appear is the missing. Alternatively, in the XOR method or in place index marking to identify the duplicate and the missing number efficiently. So here is the code given by your side. So I have just rewrite this code here. You can see I have used map method and XOR method. So that it gives us it tells us that the missing number efficiently. So the we first populate a map with the counts of each number. Count map get number. Then we iterate from 1 to n. The number with the count 2 is duplicated. The number that is counted 2 is a duplicate I. If I is equal to 2, it will be duplicate, and the number not in the map is missing one, and it I count has I missing is equal to I. So here is the five code which I have explained in my video. Thank you. Have a nice day.